Very well. 12 parts. Wow. So let's go to the podium. Who got it correct? I think Siraj got it correct in the podium. And yeah, Sean.
Yeah. So, well, if this is correct, then that means that every finite group is cyclic. So that's not the correct statement because you can find groups of order 4 which are not cyclic. So it's a wrong statement.
Yes, very well. Let's go to another question. Question. I think all of the podium members got it correct. Yeah, sure.
Oh, right. So here, so there is a theorem that you can decompose groups of the form Z to N. For example, Z12 you can write down. So you find a prime decomposition of the integer 12, so 3 times 4, and then you have an isomorphism of Z12 to Z3 cross Z4. So in the above option, for example, you just place every factor and decompose it like this, and you see that you end up in the same group. So it would be a correct option.
Very well. Interesting. Okay.
So if two groups are isomorphic, then isomorphism is in the first place by ejection. So it means both groups must have the same number of elements if they are finite. So now in this case, you just compute the order of these groups. So it would be 2 times 9 times 14, and then you compute the other 4 times 6 times 12, and you see that they are different integers. So the orders are different, and therefore there cannot be an isomorphism between the two.
Very well. Just a little point that please don't write answer in chat box. Interesting.
Okay.
It's like converse.
Yeah, so we know the Lagrange theorem for finite groups, and we also know that the converse is not true, and that was precisely the converse. So
Yes.
it's incorrect. And there are counterexample you can find, alternating groups of order 4 and so on. But everybody at least know that this is not true. If you don't remember counterexample by heart, it's okay, but you should at least know that this is not true.
Yes, very well. Let's go to the next one. Okay. Let's go to the podium, then let's go to the chart.
So integral domains are basically rings where you cannot find two non-zero elements and multiply them and get a zero. So, for example, fields are integral domains, so where you find inverse to any non-zero elements. And the P is a field, if P is a prime. Well, sorry, sure. So P is a prime. So Z11 is an integral domain in that by that definition. And for Z6, you can just find 3 times 2 equals 0, and 3 or 2 are not 0. So that's not the correct option. And similarly, you can construct two matrices as you see in the picture, which would multiply to 0, even though both the matrices are non-zero. So the correct option is Z11.
Very well. Let's go to the I lost a bit connection, but yeah, I will just reshare, so everything is all right. I would assume so. Okay. Shah, can you see the screen properly?
Yes, I do.
Okay.
Well, it's stretched.
Stretched.
But still, I can see it in full strength, so no problem.
Okay. No, I mean so that the other the participant can also see the. So that's the podium. Yeah. And then explanation. Yeah, Shah.
Yeah. So that was the Heinz-Boll theorem, which says that a compact subsets of Rn are precisely closed and bounded subsets. Okay, and now the unit sphere is both closed because it's solutions to polynomial, and it's bounded, you can see. So it's compact. The interval which is open from 0 and closed to from 1 well, it's not a closed interval because it's open from one side. So it's not a compact set. And then you have what is, I think you, okay. I don't see, you're hiding one of them. Let's see.
I don't know.
Yeah, right. So Z is unbounded, so therefore it's not compact either. So the only option is S1, the circle, which is both closed and compact, closed and bounded, which is compact.
Let me stop share and share again. So I don't know what was the. So it's all right now, Shah?
Oh, yes. Yeah.
Okay, let's go to the next question. Interesting. What's wrong with the statement, Shah?
It's a correct statement. I mean, it's a well-defined statement.
Yes, but why
No
is
ambiguity.
it false?
So the countable intersection of open set is never open, I mean, not always open.
Okay. So, okay, let's go to the.
Yeah. So you take the intervals from -1 over n to 1 over n, and it shrinks as you increase n, but it always contains 0. So the intersection would contain only 0, which is a closed set. It's not open. So this is a counterexample where a countable intersection of open set is not open.
But
So the statement was incorrect.
okay.
False.
Yeah, I got confused myself. I think we have 4 to 5 more questions. Interesting. Sometimes when they answer like incorrect to an obvious question, then I get confused too.
Um, So here you take the singleton set when we're in, and then you take the union. So it would be 1 and so on. But it goes to 0. So 0 is a limit point because you have a sequence converging to 0, but 0 is not in that set, so it's not a closed set. It's a counter example to, you can take even rational numbers and so a singleton set which contains a rational number, and then you take the union. That would be a countable union of closed set, and then the rationals are not closed because you can have a sequence of rational numbers converging to an irrational number. The limit point of rational number is the whole real line. So that's basically another counter example. Yeah.
Very well. So group ones. Encouraging. Well done, Siraj. Yeah, sure.
Well, that was something I said already, that if you have continuous function, then it reserves compactness. The image of complexity is compact.
Yeah, very well. Very good. Don't go, Dildar.
So you can explicitly write down a continuous bijection. But you see one in the example, but it's a bit complicated. You can write down, I think, the tangent inverse from 0 to 1. And then maybe not 1, but 5/2 or something. And then if you have two bounded open intervals, then you can write down also a bijection you can construct. I think you should learn this, how to write down functions between intervals which are bijective and non-bijective and so on. Just practice this.
Very well. Good hint. I think this is the last or second last question.
I think they should make this correct. Answer it correctly.
I will give a hint at the last second. There is 3 and 2 in the dimension. Okay. Well, the podium preserves. And yeah.
So again, compactness. The unit sphere R3 is closed and bounded, so it's compact. And R2 is closed but not bounded, so it's not compact.
Good.
It's parts. So answer is part.
Very well. I think this is the last question.
Okay.
Interesting. And let's go to the last bit of explanation by Sean.
So the complement of rational is irrational, and you take some irrational number x, and then construct a sequence of rational numbers converging to that, and then by continuity, at the bottom of the screen, you see that the limit of qn would actually go in. So you can just continuously extend to the whole line by just being constant.
Very well. Thank you. And we go to the final podium. Well done, Hamza. And well done, Maria. Great job, Siraj. And also Uzma and Sidra. So very well done, guys. So that would be the end of our test today. So thank you everyone for participating, and congratulations to all of you. You did amazing. Special congratulations to top five students. And thank you very much, Shah, for your time and for the
Great fun. Thank you.
explanation. You did a great job at explaining it in a very